Hello everyone. Welcome back to another episode of Mr. Houston's Math. I am your host, Mr. Houston. Today we'll be learning how to add fractions. Before we begin, we should probably review what we already know about fractions. Let's get started by defining what a fraction is. A fraction can be defined as a numerical quantity that is not a whole number. In other words, a fraction is a value that is less than a whole. Today we are going to learn how to combine two or more of these values to create one value. In doing this, we are going to learn the steps needed to complete this operation correctly. Let's get started by looking at a few examples. Here we have example number 1. Now looking at example number 1, we have 1/5 plus 2/5. This question is asking us to combine fifths, two values that are values of fifths, right? So, with that being said, that means that the denominator, these two values, these 2/5, are going to remain constant. The denominator does not change. So, if we keep this in mind and we add the numerators, 1 plus 2 equals 3. Carry the 5 over, the denominator stays the same. We get a final value of 3/5 as our answer. Now, someone who is learning this for the first time might have a couple questions of their own. One question might be, why can't the denominator change? Why is it so important to keep it the same? Another question might be, why can't I just add across? 1 plus 2 equals 3 and 5 plus 5 equals 10. That's what seems the easiest to me. Now, while this method might seem the easiest to someone who is learning this concept for the first time, someone who has mastered this concept knows exactly why we can't solve this question that way. Let's look at example number 2 to help us answer some of those students' potential questions. So, example number 2 is asking us to combine two half values, right? So we have 1/2 plus 1/2. So if we were to use the method that might seem the easiest to a student who is learning this for the first time, just adding the values across at face value, we would get 1 plus 1 equals 2, and 2 plus 2 equals 4. That simplifies to 1/2. Now, something's not right. If we added two half values, how did we get another half value as the final answer? Now, like I said, someone who has mastered this concept knows exactly why this is incorrect. However, if this is new material for this person, they probably needed to see this example to know why they can't just add straight across. We know that there's no possible way that two halves will equal another half. Two halves most definitely equal a whole. However, this just goes to show you how important it is to make sure that the procedures that you use to solve problems are foolproof. This means that the earlier on you master the correct procedure, the more it'll be useful to you later on down the road. Always remember to do the correct procedure. It's going to take you a long way. All right. Looking at example number 3, we have 1/4 plus 2/4. Okay? So once again, this question is asking us to combine fourths. That's our denominator. So if we add the top values, the numerators, we'll have 3, and we keep the denominator constant, 4. 1 plus 2 equals 3. 4 is the denominator, remains the same. So 1/4 plus 2/4 equals 3/2. Remember, you're combining fourths. Something that'll help you in the long run, if you get a little confused or might feel a little stumped, just remember, if you started with fourths, you're ending with fourths. That's the value, or in this case, example 1, you started with fifths, you're ending with fifths. You're combining those values. Now let's take a look at example number 4, our last example. Example number 4 involves two fractions that have different denominators. In order to solve this problem, we must first make sure that the denominators are the same. In order to accomplish this, we must find the least common denominator. So, that means we must get the denominators to reflect a value that is 1, identical, and 2, factors of each other. So 5 times 2 equals 10. So we know that we need to get these denominators to have a value of 10. How are we going to do that? It starts with multiplication. So 5 times 2 equals 10. So boom, we know that we're going to be multiplying these numbers by opposites of each other to get the value. So this side, to get 10, we're multiplying by 2. This side, to get 10, we're multiplying by, you guessed it, 5. So you can write the number to the side off to make sure that you remind yourself to multiply, but just know that that's the step we have to take to get these denominators to have a value of 10. However, something that is extremely important and we cannot forget is that what we do to the bottom, we must make sure we always do to the top. So any operation that we do to the denominator has to be done to the numerator as well, or else the problem won't be correct, your final answer. So on this side, since we multiplied the denominator by 2, we must multiply the numerator by 2 as well. So we'll have 1 times 2 over 5 times 2. On this side, we multiplied by 5 the denominator, so we'll have 5 times 2 and 5 times 1. So we have these values written off to the side and we know that we have to multiply. But that looks kind of sloppy, doesn't it? Let's rewrite these values so it looks easy and clean and we can operate it. So we'll rewrite the values taking out the multiplication. So we multiplied 5 by 1 and got 5, and we multiplied 5 by 2 and got 10. That looks much cleaner, right? That's our first value. On the right-hand side, we multiplied 1 by 2 and got 2, and we multiplied 5 by 2 and got 10. Now, the fractions are written in a way that we can solve them. The denominators are the same, the numerators have been adjusted, and now we can do the methods that we did in examples 1 and 3, where we add the numerators and keep the 10, the denominator, as a constant. So in this case, we're combining tenths values. So 5 plus 2 equals 7 tenths. And that has been another episode of Adding Fractions with Mr. Houston.